there was a couple of ways we could know a chemical change had occurred. Okay, there are some ways we could know that a chemical change had occurred. What was one way that you knew a chemical change occurred? I can call on people specifically if you guys want me to. We talked about, there was a sentence, it was like, old grandma's country pies taste lovely.
What was the question again?
The question is, how do you know if a chemical change has occurred? So remember, with a chemical change, you had one substance, you did something to it, and now you have new stuff. Okay, so there was a chemical change occurred. So remember, like physical change would be like me ripping something. I still have paper, or phase change. So how do we know if a chemical change has occurred? We had that sentence like, old grandma's pies taste, old grandma's country pies taste lovely. Anybody remember what any of those?
A change in color?
Very nice, Alexa. The change in color was one. All right, anybody remember another one?
Temperature.
Very nice, a temperature change. Okay, if it gets hot or cold, that was one. That's two. Anybody got another one? So that would be the T and the C. Old grandma's country pies taste lovely.
Is odor one of them?
Yes, odor is one of them. Very nice. If you have a smell, okay, if there's a change in smell, it could be something as simple as like cooking, right? I mean, when you first, thank goodness, chicken doesn't smell a lot better when you cook it than when it does when it's raw, right? So that's a change in odor. Very nice. That's three.
Light.
Very nice. Light. If we have light production, so remember we talked about the fireworks. So they produce light. They're not lit up before you actually set them on fire, right? So when you set them on fire, then you all get this light production. Or like a glow stick, right? If I crack a glow stick, that's a chemical change because then it lights up. All right. Anybody else?
Precipitation.
Precipitation. Now that was the one that I was going to show you guys a demo for. Very nice. Precipitation, I said you could take two liquids, mix them together, and you could actually get a solid, right? And that sounds really weird. So let me see. Old grandma's country pie tastes lovely. We're missing one more.
Gas.
Gas, all right? So if you see a gas evolve, then you also had a change, a chemical change. Now, here is the weird thing though. How do you, most gases are like colorless. Like there's gas around me right now and gas around you is air. So how did we know if a gas suddenly formed? What would you see? Anybody remember?
Bubbles.
Bubbles, very nice. So I don't know if you guys remember, I said, remember, be careful, don't let one rip in the pool because people see bubbles and they don't know what you did. So a gas, right, you usually see bubbles, or that's why you see like in your soda, those little bubbles in there, that's a gas, okay? All right, so I said I was gonna show you evidence of a chemical change. Let me find my true safety glasses, okay? I have to demonstrate safety for you guys. Let me put on a pair of safety glasses. All right. These are pretty gross looking. All right, I'm gonna put on these glasses. I have safety glasses, I swear. I'm gonna put on these. These are safe enough. Only because I've done this a couple times. All right, so you guys tell me. So I have two. Let's see if I can get this. All right, I have, oh, here we go. All right, I have two liquids. Let's see if you guys can see this. All right, so one of them is called, this one is lead nitrate. So it's gonna be kind of cool. Later on in the year, we're gonna learn how to go from this to the name of it and write them like this. So this is lead nitrate, PB is lead, this is nitrate. All right, and then this one, KI, this is potassium iodide, okay? So you can see These are two liquids. Everybody see that? Liquid, liquid. All right. So I already poured some of this in this test tube. So this is the same thing. All right. And then I haven't poured anything in this test tube yet, but I'm going to pour some of this in here. So pour a little bit of this in this test tube. I'm going to pour just a little bit too. All right. That's even more than I wanted to pour. But anyway, all right. So everybody can see what I'm doing? Yes. You can just.
Yes.
Okay, good. All right. So here we go. We got to see, how do we know that this is going to be a chemical change when we mix the two of these? All right. So I'm going to pour just a little bit. If we were in class, I'd let you guys do this. But all right, I'm going to pour a little bit of this one into this one. All right. Here we go. All right, what was the first thing you noticed, the most obvious thing you noticed about
The color change.
color change? Very nice. It is super yellow now, okay? And remember, this is what they looked like. All right, so now I've got this super yellow substance. And then I'm gonna see if I can get close enough so you guys can see it. Let's see. Can you, let's see if we can hold it.
Did it get thicker?
Ah, yes, it did. Because it actually formed a solid. Can you guys see like the powder in it? Let me see. Let me be still for a second.
Is it at the bottom?
Yeah, it's at the bottom. You see it? So I'll show you one I did the other day. You can kind of see, oh, maybe if I turn it this way, you can see it a lot. There you go. So this is what a precipitate is. You can see it good there, right? So a precipitate, you mix two liquids and somehow they form a solid. And we'll talk about what actually happens later. This is called a double replacement reaction. So basically, when I mix the two liquids together, two of them are like, we don't like each other. And so they just make a powder. That's basically what happens. So you can see, now you can see it really good. There we go. So that is another example of a chemical change. It's a precipitate. Okay. All right, so that's what the demo I promised to show you guys. Get me back on top. Okay, I missed it. All right, so that is an example of a chemical change. So what I thought we would do, I almost dropped something, is I thought we'd do a Kahoot. Everybody down for a Kahoot? Yes? So we're gonna do it.
Yeah.
Cool. We're gonna do a Kahoot. If we finish so there's some questions in there that we haven't really talked about, but I want you to think about it because I think you guys could do it. Like, we haven't really talked about when we have a phase change. We've talked about whether something is gaining heat or losing heat, but we haven't talked about what those particles are doing. Like, are they speeding up or are they slowing down? But I think if you think about it, you can figure it out. So we're gonna do a Kahoot. And it may take a little bit longer because if a lot of people get the question wrong, then I can talk about it then. So you may want some paper nearby just in case I talk about some stuff we haven't talked about. But then other than that, we're going to do Kahoot. If we have time, I'll start the homework for you. But otherwise, the homework is going to be some video notes. But it's like 15 minutes and it's over. We're going to start talking about mixtures, okay, in the video notes. So we're going to talk about homogeneous mixtures, heterogeneous mixtures, elements, and compounds, but it's just 15 minutes. But if we finish the Kahoot early, I'll start it so that you can have less of the video to watch, okay? All right, so let me open up the Kahoot so we can get started on that. Let's see. All right. We are going to start the Kahoot. I have it on this screen. This. And I'm going to Recognize. Here we go. All right, let me share screen. And here we go. All right, we just about ready. Got still a couple people. Wait on a couple more people. I'm gonna start in about I'm gonna start in 1 minute. Everybody should be logging in play. All right. If you're not playing, make sure you send me a reason why you're not playing. All right, here we go. Less than 10 seconds. 3, 3, 2, 1. All right, so let's talk about this. So it'll help you on the next ones. All right, so hopefully, it's rusting is definitely chemical, okay? And so we haven't done a lot of, this is why I want to do this, because we haven't done a lot of review of properties versus changes. But for you to have a change, you literally have to be doing something, or something had to happen. So if something rusted, then it actually changed. So that should be a change. And it's chemical because you've made some new stuff, right? Like it doesn't look like the same stuff, and you can't really take rust and go backwards, okay? So it's definitely chemical. And then a property would mean that it just has the capability, but change means you actually did something, or something actually happened. So good job. All right, here we go. All right, so think about this. So you got some water and it starts to form bubbles. What's happening? 10 seconds. 5, 4, 3, 2. Very nice. All right, so let's see. All right, so if there's bubbles in the water and it's on a burner, this is like a stove, or there's heat being applied and you're forming bubbles, it is turning into a steam. You are boiling. Very nice. Okay, so think about, it's a liquid, this is a liquid, and it's turning into a gas, so that's boiling. Okay, and if you guys have questions as we're going through, just unmute and ask your question, because chances are somebody else has that question. All right, question number 3. Ten seconds. You guys, let me trick you again. So remember, I've asked this question about 3 or 4 times now, so you probably can expect it to see it on your test whenever we have it too, okay? We got to get this at some point. Dissolving, all right, as a reminder, dissolving is when we have, so like if I have a container and it's got some water in it and I add some salt or sugar or whatever, and I stir it up and it looks like it goes away, okay? But it is still, now it's just like salty water. I didn't really make anything new. And technically I can reverse it, because if I can boil off this water or let it evaporate, that salt or sugar is still gonna be there, okay? So that should be a physical change, okay? And again, not a property, because something is actually happening. This says dissolving, so something's being done, okay? This is actually being done, so it needs to be a change. It needs to be a change. All right. Okay. Density. Much better. Very nice. Nothing's happening, so no change. Okay. And density is just like how much weight you have in a certain space. Remember, it has to do with mass and volume. So it's just physical. There's nothing, you're not going to make anything new. Okay, you're not making anything new, so that is just physical, not chemical. Nice. This is a much better score. Anybody have questions on this one? Okay. Somebody's on a streak. I can't see it though. Looks like, I think it might be Zarina, maybe. All right, what do you think this is? Very nice, solid. Okay, so think about how a solid's particles look. Okay, and these little lines right here is telling me that it's vibrating. They're moving, but they're not moving very far because they're stuck so close together. Good. Anybody have questions on that one? Okay. Ooh, sorry. All right, here we go. All right, giving you a lot of time on this, so think about this. What do you think would happen to the particles in a metal if you heat them up? If you heat them up, what do you think is going to happen to those particles? I gave you a lot of time on this, and we haven't talked about this, but I want you to think about it. Think about what makes sense. Got about 10 seconds. Very good, very good. Okay, so this is one of those questions that we did not talk about, but I wanted you to see what you thought made sense. So, and a lot of you got it. And if you didn't, that's okay. So if you have a piece of metal, okay, and you have particles in that metal, okay, when I tend to, for instance, when I'm cold, I tend to move very slow. I'm very lazy and lethargic. I don't want to do anything. But if I'm hot, I want to be outside, I'm moving around. So particles are the same way. When you heat them up, they start to move around. And if they are constantly bumping into each other, okay, they're going to, I'm looking at this gold block down here. Okay, they're going to speed up. They're going to speed up, all right? And if they speed up and they're constantly bumping into each other, the metal is going to get wider. Now, we haven't talked a lot about this, but that's exactly what happens. That's why, anybody ever notice that a sidewalk has cracks in it? Like the actual slits in it. The reason why is because in the summertime, most things, when they get hot, they get bigger, they expand, okay? So a sidewalk has cracks in it so that in the summertime, when the concrete starts to expand, we can't see it, right? It's happening, but it's very expand and it won't buckle up. So if you ever been on a hello? Oh, there it goes. All right, let me see. All right, so you can hear me here. Oh. All right, can you hear me now?
Yes.
I don't know what happened. All right, so I was saying, oh no, did it close my Kahoot game? Maybe not. Oh, it didn't. Okay, good. Let me just share my screen again. I was saying though, that on the sidewalk they have slots because in the summertime when the sidewalk heats up, it expands, and so that keeps it from buckling up. So if you've ever been on a sidewalk and it's all busted up, it's because it heated up and expanded. All right, here we go. Let's see. Next. All right. So this is the particles being close to each other. The force of attraction, just like if you're attracted to somebody, do you get closer to them or further away? Very nice. When a gas changes to a liquid, the force of attraction increases because they get closer together. So if you're attracted to someone, you tend to want to be closer. And that's what happens in a gas. If those particles are super far apart and they change to a liquid, they get closer, then that force of attraction increases. Very good. All right, here we go. All right, heat removed from a liquid, removed from a liquid. Got about 15 seconds. Here we go. Very nice, very nice. Heat is removed from a liquid. So you're starting as a liquid. Take away heat or you cool it down. If you cool down a liquid, you were going to freeze it. Good job. And again, if you have questions, just either unmute or put it in the chat. Definite volume, definite shape. That means they're both definite. Neither one of them changes.
Hey, it's two choices because my computer is slow.
Okay, red is liquid, blue is solid, yellow is gas. Sorry. Red liquid, blue solid, yellow gas. Three seconds. 2, 1. Very nice, very nice. All right, so definite and fixed, that means neither one of them changes. So that's a solid. All right. Here we go.
It's going slow.
I'm sorry, Cam. Red is gas, Cam. Blue is liquid, and gold is solid.
I didn't even see the question.
You can even see the question, Cam?
It's like it's still on the scoreboard. Like it's going way slower, and it's just now going to the question.
Oh, okay.
Mine's
Yeah.
behind.
Are you doing both on the same device, or are you on your? Oh, your computer is showing.
I'm doing the Kahoot on my phone. I'm on Zoom on my laptop.
Okay, I got you. All right. Well, I'll try to read the question and the answers. Okay. All right. Cam, are you seeing the scoreboard right now?
No, I'm seeing the question.
Okay.
It says
All right.
17 seconds.
All right. I'm going to read the next question. Here we go.
Okay.
If heat is removed or added, is heat removed or added when evaporation occurs? So if it's added, then you put blue. If it's removed, then you pick red.
Okay.
So this is evaporation. Heat removed is red. Heat added is blue. This is evaporation. About 10 seconds. Evaporation, if you haven't answered yet. Very nice. Heat is added when evaporation occurs. Okay. And if you guys are, if I don't know if someone's not answering, but it'll go quicker if once everybody answers. I'm not rushing anyone. I'm just saying if you're just in there and you're not answering at all, then it slows down the game a little bit. All right, here we go. Oh, Michael has a streak. All right, here we go. Next question. Water droplets build up on a cool surface. What's the name of this phase change? Is it red, melting? B, freezing? Blue, freezing? Gold is boiling and green is condensation. Water droplets on a cool surface. Red melting, gold boiling, blue freezing, green condensation. Very nice. Water on a cool surface is going to be condensation. So the water builds up. So that means it turns into a water. So for my people who put freezing, this is not saying the water gets cool. It's saying it cools off and then it turns into a water. So that'd be condensation. Let's see. Okay. Sorry for the guys who is going slow. Let me see if I can put the question in the chat. All right. Ripping a sheet of paper. Ripping a sheet of paper in half is red, chemical property. Gold, chemical change. Blue, physical property. Green, physical change. Ripping a sheet of paper. Very nice. I did something again. I actually did something, ripping a sheet of paper. That's a physical change. Okay. It's not chemical because at the end of the day, it's still a sheet of paper. And it's not a property because I actually did something. Okay. All right. Here we go. Color change is a red, chemical property. Blue, physical property. Gold, physical change. Green, chemical change. This is color change. Red, chemical property. Gold, physical change. Blue, physical property. Green, chemical change. Very nice. Now, I one on purpose because I wonder if people will put physical property. Now this is a color change. Color change. Color change would be a chemical change. So it's like what I just did, where it went from clear to yellow. That's a color change. All right. Flammability is a red, physical change. Blue, chemical property. Gold, physical property. Green, chemical change. This is flammability. Flammability. Very nice, very nice. It is a chemical property. Now, if I said I set something on fire, that would have been a change, but flammability is just a property. Very nice. Let's see if we can get maybe 2 or 3 more questions in. Which state of matter has atoms or molecules which are close together and free to move about? That's kind of tricky. They're close together. They can slide or glide past each other. Red is gas. Gold is liquid. Blue is solid. Close together, but they can move. Close together, but they can move. Very nice. So the only reason, so these are, if you really had to read this one, solid, they are close together, but they can't move freely. Gas, they can freely move, but they're not close together. So this one's a liquid. All right. Maybe 1 or 2. Which state of matter is this? Liquid, solid, or gas? It's a bunch of particles and they're spaced far apart. Liquid, solid, or gas? Liquid is red, solid is gold, gas is blue. Yes, all correct. Very nice. All right, let's do 1 or 2 more questions. Let's see. We'll do 2 more. Liquid wax drips on a table and turns into a solid. Liquid wax drips on a table, turns into a solid. This phase change is red is freezing, gold is condensation, blue is melting, green is boiling.
What was red again?
Red is freezing, blue is melting, green is boiling, gold is condensation. Very nice. Now, I like this one because, you know, a lot of times we think about freezing, we think it's cold, but cold is very relative, right? So if wax drips on a table and turns into a solid, it is freezing, even though it's not cold. All right, we're going to end the game here. It looks like you guys did a good job, though. Serena, who else we got? Kaya and Michael. All right, so, and their runner-ups were Gabby and Natalia. All right, so let me just tell you really quickly what we got for